Hey class, today I'm going to show you the chapter 27 notes, which talks about inferences for regression. If you remember, we talked about simple linear regression back in Unit 3. So before we start with the new stuff, I wanted to just review linear regression back from Unit 3. So if you could see here, I have a list of anxiety level versus math test scores. And I did give you a copy of these notes. They'll also be posted online. So the first thing it asks you to do is enter the data into your calculator and make a scatter plot. So into list 1 and list 2, you're going to click your stat edit and you're going to put in all of the data. List 1 is your anxiety level and list 2 is your math test scores. And then we're going to make our stat plot. So we hit our second stat plot, make sure only number 1 is on. Select the scatter plot, which is the first one. Make sure you select the correct lists for X and Y, and then we always hit graph and then zoom 9 so you can see that scatter plot. And then I just ask that you copy that over. In order to get the scale on the X and Y axis, if you just hit trace, it'll give you the coordinates of every single point. This doesn't have to be super exact. Remember, we're just looking for basically the shape of this. So it's nothing super impressive, but I made the scatter plot there for you. Anxiety level is predicting the math test score. So then the question, does there appear to be a linear association between them? Remember, we talked about strength, direction, form. So the strength would be weak, direction, negative, and the form would be linear. So there appears to be a weak negative linear association between anxiety level and math test score. That's your context. And then that supporting statement, generally as my anxiety level increases, my math test score decreases, but it's nothing pretty strong. It's actually pretty terrible. To find the correlation, in case you forgot, you're going to hit stat calc and then down to number 8, which is our linear regression. Select your correct lists, X1, X for list 1 and Y for list 2, and then hit the calculate again. And then if you recall, A is your y-intercept, B is your slope, and then you have your R and your R squared. Remember, R is your correlation coefficient. So that's what problem 3 asked us for. So our R is negative 0.52, and it says, what does that indicate? Well, we said that right up here. Don't forget your interpretation of R squared. 27.6% of the variability in Y, which is math test score, is explained by its linear association with X, anxiety level. Okay, so don't forget that. This is a good review to help us for the AP exam also. And then when you create the model, again, you're going to use the numbers from the calculator, the A and the B. A is the y-intercept, B was that slope. But don't forget your little hat. This means the predicted math score will equal, and we do it backwards in statistics. We put our y-intercept first and then our slope. So you can see that there. And then it asks, is a linear model appropriate? Don't forget to mention 3 different things. You want to mention the scatter plot. You want to look at the residual plot and the correlation coefficient. So there's 3 things you have to comment on at all times. So you could see the linear model is appropriate. I mean, there's a weak negative association in there. You'll have to make your residual plot. I'm going to spare you on that. Remember, well, I guess I could show you. After you run the regression, like after you get this stuff, then you have to import the list of residuals into list 3. So go back into stat edit, arrow up to list 3, like highlight that list 3, and then this blue list button, you want to select that, and that's going to give you your residuals. So find your residual list minus 8, and then that's going to make list 3 the list of residuals. Then, in order to graph that, I want to do X versus my residuals, so list 1 versus list 3. So I'll select that, and then I'll change this to list 3, hit graph, and then zoom 9. I might have hit list 2 again. I did. So hit list 3, and then graph, and then zoom 9, and then there's your residual plot. Okay, so make sure you comment on the scatter plot, the residual plot, and the correlation coefficient. If you flip over, then it asks to interpret the slope. So remember, on average, don't forget that keyword on average, or that key phrase. On average, for each additional unit of anxiety level, the model predicts a decrease of 4.486 points on the math test score. So that, just don't forget that interpretation. And then the y-intercept, that also when x is 0. So when a person has no anxiety, meaning x is 0, the model predicts the math test will have a score of 91.6. And then lastly, in the review, it says, does this prove that anxiety interferes with students' performance? And hopefully you know that answer is no. In order to show causality, we definitely have to run a well-designed experiment. Okay, so that's your review. Now let's talk about inferences for regression. So the slope and the y-intercept that we saw in the last problem, in fact, it's right down here. This slope and this y-intercept came from a sample set of data. So those are your B0 and your B1. Okay, they are the slope and the y-intercept from our sample of data. Beta naught and beta 1 are the true slope between those two variables. And what we can do is use the sample's slope and y-intercept to estimate the true slope and y-intercept between the variables. Now, we already kind of talked about how the y-intercept really isn't that interesting to us and doesn't really tell us a lot. So we're going to run a t-test on just the slope. What does the slope from my sample tell me about the true slope between the two variables? So there's a couple conditions that we have to talk about, and I'll show you the hypothesis when we do the examples. So we need to just make sure that the scatter plot looks straight. Why would we want to find the slope, the true slope between two variables, or estimate it with a confidence interval if we don't even have a linear association to begin with? We just need to make sure also that the data values are independent of each other, which will usually happen. We need to also make sure that the residual plot shows a uniform spread. Now what that really means is the variability of y should be the same for all values of x. So just make sure, and I'll show you an example in a minute, that the variability doesn't increase as x increases, that there's just a uniform spread in that residual plot. And then lastly, we need to just show that the histogram of the residuals is unimodal and symmetric. Basically, at each x value, the distribution of the y values should be normal. And if you show a histogram of the residuals, that's going to take care of that condition. Okay, so how do we run this test? Well, what we're going to do is get our t-score. We're going to take the slope, which we're going to get from our regression printout, so that'll always be given to you. And then you're going to subtract what we hypothesize is the true slope. Now, we always hypothesize that the true slope is 0. I'll show you that in a minute. So we're just basically subtracting 0 here. And then we're going to divide it by the standard error of B1. And the standard error of B1 is going to be this number right here. So these numbers will always be given to you. Let's actually go through this regression printout, because we were only ever interested in the slope and the y-intercept of the regression equation, but now there's some other interesting pieces to this printout that now we're ready to look at. So up here, this is the standard error of the residuals, and it's basically just the typical prediction error. You know that the residuals vary for each value of x, and this is just a typical prediction error for a given value of x. Your degrees of freedom will be n minus 2. That's a little bit different. In multiple regression, the way that we find the degrees of freedom is n minus the number of predictors minus 1. And in this case, the number of predictors is 1. So we have n minus 1 minus 1. So n minus 2. If you have no clue what I just said, that's perfectly fine. Just remember that this, in a regression slope t-test, your degrees of freedom is always sample size minus 2. Then we have the standard error of the slope, and that's just how much we would expect the slopes to vary from sample to sample. Then we have our t-score, so we don't need to calculate that. And we also have our p-value. So I gave you the formula to calculate your t-score. It's beta 1 divided by the standard error of beta 1. So here, beta 1 divided by the standard error of beta 1. And that gives you your t-score. So I've seen questions where they might leave out the standard error, leave it blank, and they'll ask you to find it. And you just need to know that B1 divided by the standard error of B1 is going to give us this t ratio. So I've seen some pretty cool multiple choice questions about that. And then this is your p-value. And remember, we're only doing this for the slope. We're only running a regression slope t-test. So I don't care about the standard error of the y-intercept and then the t-score and the p-value for the y-intercept. Okay, so let's try a problem. It says investigate the association between average monthly temperature and electrical usage in kilowatt hours for a home. So you don't have to stress because you're going to be given everything that you need. The scatter plot, the residual plot, the histogram of the residuals, and you also give the regression printout. And all you need to do is comment on those and then use the numbers in the regression printout. So is there evidence of association between these two? Now that's not a chi-squared. I'm talking about quantitative data, and if I want to show there's an association between quantitative data, then I'm going to have to run my regression slope t-test. So my null hypothesis will always be beta 1. The true slope between the two variables is 0. If I'm saying that the slope between the two variables is 0, I'm telling you that there's no association between average monthly temp and electrical usage. You don't have to write that in words. I put that there just to clarify. You just need to write that beta 1 equals 0, that there is no association, and then the alternative is always a two-sided test, that there is an association. If the slope isn't 0, then there's an association. Then all you need to do is comment on the plots given up here. The association in my scatter plot has to be linear, so I said that there, that the association between average temp and kilowatt hours, make sure you're using context, appears to be linear, which it clearly does. Also, I need to comment that these data points are independent of each other. So I said that the months are independent of each other, meaning just because the average temperature was 55 in May doesn't affect the average temperature for, let's say, December. There has to be uniform spread in the residual plot. So if you look here, you can kind of see the spread doesn't really change. I don't see a small spread here and then it getting wider as X increases. So I do see uniform spread in my residual plot. And the histogram of the residuals is unimodal and roughly symmetric. So since I've met those 4 conditions, so I say 2 about this, 1 about this, 1 about this, then I name my test. It's a regression slope t-test. And then I just need to get the t-score and the p-value from the chart. Remember that my t-score is here, and then that's the p-value. So you don't have to show this, but if I took the negative 50.9 and divided it by the 4.9, that's going to give me my t-score right there. And then the associated p-value. So you just have to list them. And then you know that since my p-value is less than 0.05, that should say 0.05, then I'm going to reject my null hypothesis. And if I reject the null, then there's sufficient evidence to support the claim that there is an association between those two variables. Okay, so let me show you then how to estimate the slope. We just said there's sufficient evidence that the slope is not 0. So then, well, what is the slope then between the two variables? And that's how that's why you're going to now find a confidence interval for B1 called the regression slope t interval. So the formula doesn't change. We always use our point estimate plus and minus our critical value times the standard error. So none of that is new. So your conditions are already checked, so just comment on that. Just make sure you name it. It's a regression slope t interval. You're going to get your beta 1 from the chart and your standard error B1 also from the chart. I'm going to take you back there again just to look at those numbers real quick. Again, they come right here. So really what you're doing is adding a plus or minus between these numbers, and you're putting your critical t. Just kind of like right in here is kind of how I think about it. So that's what I did. In order to get that critical t value, remember my sample size was 12, so I needed to find the critical value at 10 degrees of freedom, so inverse t, you know how to do that. Because I'm running a 95% confidence interval, I have 2.5% in each tail, so I put 2.5%, my degrees of freedom is 10. This number comes out negative. I want you to verify that it does come out negative, but that's okay because we're gonna put it in here with the plus and the minus. So we always just put the positive, and like none of that's different. And then you see the confidence interval there, except these are not degrees. In fact, these are kilowatt hours. So I'm gonna get rid of that. Okay. And then we are ready to interpret this interval. So I put this interpretation up here. And basically, we're just going to say as x increases by 1, y increases between these values. But here's how we say it. We're 95% confident that for every 1 degree increase in average monthly temperature, so that's as x increases by 1, my electrical usage, which is y, is going to decrease because my values are negative, an average of between 39.8 and 61 kilowatt hours. Make sure you're saying an average of between those values. So that's how you run the regression slope t-test, and you find and interpret the regression slope t interval. What I'd like you to do is try example 2 and try example 3, and I will post the solutions to those on our classroom.